All right, guys, today we're going to graph these parabolas, okay? And they're what a quadratic is. So everything that has an x squared, you know, like x squared plus 4x plus 6, or x squared itself, or x squared minus 4, or whatever it is, anything that has an x squared is going to be a parabola, which is kind of this shape here. It might be upside down like this, but that's if this guy's negative, and we'll talk about that later. But most of the ones we're gonna do are gonna look like that. It's in some way, shape, or form. All right, and so I'm gonna erase all this stuff, and we're gonna graph what's called the base parabola first. Okay, and I'm gonna blow this up a little bit so we can see it better. And we're gonna do it the old-fashioned way. Well, when you think about graphing, you think about, well, I have to use an XY chart. So we'll do it that way. So the base graph is simply y equals x squared. Everything else is based on it. That's why I call it the base graph, okay? And so if we make an XY chart out of this, remember we should always pick 0, 1, and 2. So if I take 0 and square it, well, that's 0, right? If I put 0 in for x and square it, that's 0. So my first point's right there. Then if I put 1 in for x and square it, well, that's 1. Okay. And then if I put 2 in for x, I'd put it right there and square it, that'd be 4. Okay. And if I put, let's try 3 and see what happens. If I put 3 in, 3 squared is 9. Oh. Okay. You can see it's kind of starting to form. But how do I do this side? Over here, well, I have to put in a negative, right? So let's put in a negative 1. If I put in a negative 1, what's negative 1 squared? It's positive 1. So that's going to be right here, isn't it? Whoops, I missed. There you go. Can you see this is going to start mirroring itself? If I put in negative 2 and square that, I'm going to get a positive 4. Okay? So really, I only have to find these 3 points, and then I can mirror them across the y-axis. Okay? In this base graph. And we'll talk more about that in a minute here. But do you see what the parabola that I created? It's not a straight line, it's a curve. Okay? And I could, this point up here would be up here at 9. Okay? But do you also recognize that those are the perfect squares? So we went, you know, at 0 we went up 0, at 1 we went up 1, at 2 we went up 4, at 3 we went up 9. And so these here are the perfect squares. 1, 4, 9, 16, 25, 36, right? So if I went up 1, I went up, or if I went over 1, if I went over 2, if I went over 3, if I went over 4, it'd be clear up at 16. If it went up 5, it'd be clear up, way up there at 25. Okay? Have we done this before? I don't think we've done this before. But anyway. So let's do another one. Let's do another basic one. So every one that I'm going to start with here is going to be on this line. This is going to be your mirror, okay? So if we do, let's say we have y equals x squared plus 3. Okay? So let's go back to the XY chart here. I'm going to move this off a little bit so I can do my XY chart down here. If I plug in 0, 0 squared plus 3 is 3, correct? And that would be about there. If I put in 1, 1 squared plus 3 is 4. Okay? If I put in 2, 2 squared plus 3, that's 4 plus 3 is 7. So I got to go up to 7, which would be, looks like about there. I can't make a dot very good on a small graph with this pen. Right there. Okay? And now we know that the other ones would mirror that. I'm going to erase this first point too because it's terrible. We know that this other one, they should be here and here. Would you agree with that? Should we check it? Let's see. If I put in -1, -1 squared plus 3, that's 4 again, and that's that point right there. And then -2 would be -2 squared is +4 plus 3 is 7 again. So these mimic each other. These two are the same. And these two are the same, aren't they? Okay, because they mirror each other. That's part of what a parabola is. It's symmetrical. And the line of symmetry, LOS, line of symmetry, in this case, is going to be the y-axis, this line right here, okay? And that's always going to be that way until we get to the point where we add an x term. So if we had, like this doesn't have an x term, it has an x squared, but if I went x squared plus 3x plus 4, that would shift our line of symmetry. We're not going to deal with that yet. Okay, I want you to get the pattern first before we go into that, okay? So let's go to the next page. The last two that we made. From the vertex, did I go up 1 over 1 and up 4 over 2? And this one here, didn't I go up 1 over 1 and up 4 over 2? Every time that pattern holds. So once you find your vertex, all you got to do is use that pattern. And we're going to write that down here. Whoops, sorry. And on this one here, what was our initial? It was x plus 3, wasn't it? And wasn't our vertex at 3? And then this one didn't have anything, so it'd be like plus 0. And wasn't our vertex at 0? That's incredible. Let's try another one. Let's go y equals negative x squared plus 5. Okay, so now if I put in my 0, 1, and 2, so 0, -0 squared, I'm sorry, it shouldn't be in the parentheses like that. The negative's on the outside because it's got to be squared first, because of PEMDAS, this has to happen first and then the negative. And then plus 5, so that's going to be a 5 right there. Okay, and if I put in 1, I got negative parentheses 1 squared plus 5. So now it doesn't make it positive when I square it. It's going to end up being 4. So it's going to be here. And if I put in 2, because that negative is outside again, it doesn't square it. So it stays negative. So it's going to be, this is going to be a -4 plus 5 is going to be a 1. So you see it just went upside down. All that negative did was make us go upside down. But it still looks almost exactly the same, doesn't it? Interesting. Let's see something here. Let's go. I want to go back and look at those other ones too. But let's just take a look at this. How much does this change? And, oh, there's another term we got to introduce here. The vertex. The vertex is that middle point, that very first point that we came up with. This here is the vertex, okay? And when we do our pattern, we're going to measure from the vertex, okay? So let's look at this. From that vertex, how far, I'm going to write in blue now, how far did we go this way and this way? We went down 1 and over 1 from the vertex, didn't we? And then I'm going to go in yellow. We went down 4. I'm going to have to write in black. Down 4 and over 2, didn't we? Okay, does that make sense? Is that the same thing that happened on the last one? Just a second here. So, where was our vertex? Was this our vertex? We were at 5, weren't we? We were up at 5. This is the parabola pattern. This is very important. Okay? Because every parabola follows this pattern. Even when we put that x term on there, it still follows it. And then there's some other things that happen that change the pattern slightly, but it's still, we're still able to use the pattern. So from the vertex, you go up 1 over 1, or down, if it's a negative, right? And up 4 over 2, okay? And we could continue. Remember, we said they were the perfect squares, so we could go up 9 over 3, right? And up 16 over 4. Remember, these are the perfect squares. These guys here are the perfect squares. And then up 25 over 5, etc. But we only need 5 points. So we only need these two, and then mirror them, right? Okay, so if this is our vertex, we're going to go up 1 over 1, and then up 4, 2, 3, 4 over 2. Notice I went back to the vertex. I don't go up 4 over 2 from this guy. I go up 4, 2 from the vertex. Okay, does that make sense? Always go back to the vertex. 1, 2, 3, 4 over 2. Okay, from the vertex. That's why that says this right here, from the vertex. Because if you go from here, it'll get too tall. You'll be here, and then you go up 1 over 1, and then you go up 4, 1, 2, 3, 4. It's going to be way up here, and that's going to be wrong. This is incorrect. Always go back to the vertex when you're using this pattern. Okay? All right, so let's see if we can draw one. Let's look at this one. One using that idea now. All right, so let's say here we got y equals x squared minus 2. Oh, there's something else we need to talk about. How do we tell where our vertex is right away? Well, all right, so looking at this right here, that's our vertex, -2. Boom, done. Now, if we use our pattern, it's up 1 over 1. Why am I writing that out? Up 4 over 2. So from my vertex, I'm going to go up 1 over 1 here, and up 4, 1, 2, 3, 4 over 2, so here. And then I mirror that on the other side, and now I have my parabola. That's how easy it is to graph a parabola using this pattern. Once you find your vertex, that's it. You're done. You just use the pattern. You don't have to do an XY chart. Now, when we throw that x term in there, and we'll talk about that in a minute here, then you got to use an XY chart one time to find your vertex. And then after that, you can use the pattern, okay? And they follow the pattern very well. All of them follow the pattern really well. So let's try another one here. Let's go y equals -x squared plus 7. All right, so where's our vertex? Our vertex is at 7, okay? So we start there. But now, instead of going up, what should I do? My pattern says up 1 over 1 and up 4 over 2, right? But what's this right here? When that's negative, instead of going up, we go down. So I'm going to go down 1 over 1 and down 4, again from the vertex, 1, 2, 3, 4 over 2. And then I mirror them across my line of symmetry. This is my line of symmetry. When there's no x term in here, that's my line of symmetry. So it looks like this here. Boom. And we graphed our parabola. Okay? Let's try one more of those. I'm going to erase this guy here. Let's go y equals x squared minus 3. So we're going to start at -3, right? There's our vertex right there. And then we're going to go up 1 over 1. Notice I just did it on both sides right away. 1, 2, 3, 4. And then I'm up 4 over 2. And there we are. And there's our parabola. Okay? Now, the only time we don't follow our pattern is when this number isn't 1. There's no number there. It's a 1, right? Well, we did a whole bunch of factoring and stuff when that number wasn't 1. So what do we do in that case? Well, we still are going to use our pattern, but we're going to change it slightly. So let's say we got y equals 2x squared minus 6. Okay? Well, do you know where our vertex is? That hasn't changed. That's still just going to be this -6. Okay, so I'm going to be down here. Now, what we've been doing is we've been saying that our pattern is up 1 over 1 and up 4 over 2, right? Can't write. But now because of this 2, I have to multiply these up numbers times 2. These will never change. No changey. No changey. Okay? They will never change. These vertical numbers will change. So instead of going up 1, I'm going to go up 2. I doubled it. It makes it steeper. Okay, that's all that's happening. And then instead of going up 4, I'm timesing that by 2. I'm going to get 8. So this is 6 to here. 7, 8 would be there. So here and here. Notice how much steeper it is. And again, I'm still going from the vertex. I didn't go 8 from the first 2 points. I went 8 from the vertex. From the vertex. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the only thing this number does is make it steeper. The bigger the number, the steeper it's going to be. The quicker it's going to go up. Now, if it's a fraction, then it goes up slower. And if it's negative, it goes down slower or up or down faster if it's negative 2 or whatever, okay? Negative goes down. That's all it changes. Okay, let's do another one of these real quick here. Let's try this one here. Let's go, I'm going to slide clear over to this way. So let's go, I got y equals negative 3x squared plus 7. So where's my vertex at? Clear up here, right? At 7. Okay, now, I'm supposed to go up 1 over 1. But first of all, this is negative, so it's going to go down, right? And then I got to times this by 3. So I'm going to go down 3 from the vertex and over 1 like that. Now, my next step is supposed to be up 4 over 2, right? But I'm going to take that times 3. So that's 12. I got to go down 12, right? And notice these didn't change, did they? They're still 1 and 2. So I'm going to go, this would be 7, right? Down 7, 8, 9, 10, 11, 12. We'll be clear down here, really steep. Okay, there's my 2. I'm going to make this bigger so I can hit them. Ding, ding. And there. Oops, I don't want that. I'm going to undo that guy. Here we go. And if you don't make the noise, it doesn't work as well. Yeah, got to go like that, okay? All right. Does that make a little bit of sense? So we're still, nothing really changes. I mean, when we put this number here, we just make it steeper, okay? And the negative still makes it go down, positive goes up, but we're still going to use this pattern over here. And we change the vertical portion of it. Notice if it got, if we multiplied the 2 by 3, then it'd be way out here wide, and it really wouldn't change that much. Okay, so the horizontal part, the over, never changes. You're always going to go over 1 and over 2. How much you go up or down will change based on this number. All right. Now let's try a fraction real quick. Let's say we got y equals 1/2 x squared plus 5. Okay, so again, where are we starting? Well, we're going to start at 5. So 1, 2, 3, 4, 5. There's where our vertex is. That part didn't change, did it? Okay, so let's look at our pattern there. I'm going to erase this line here. So again, our pattern is up 1 over 1 and up 4 over 2. So now instead of multiplying by 2 or 3, we're going to multiply by 1/2. Well, what's 1 times 1/2? 1/2. So we're going to go up 1/2 and over 1. And so up 1/2 would be right in there somewhere, wouldn't it? Is that up 1/2? Looks like it to me. And then we've also got to take this guy times 1/2. Well, what's 4 times 1/2? 1/2 of 4 is 2. So now we're going to go up 2 over 2. So from the vertex again, there's our vertex. We always go back to the vertex. So 1, 2, 1, 2. So here and here. Made it a little bit shallower. Okay, that fraction makes it shallower. So the bigger this number is, the steeper the graph is. And the smaller the number gets, the less steep. So if you think about a satellite dish, if you're looking at a satellite dish here, okay, this is a really shallow parabola, isn't it? Okay. And it'd be, we're talking, instead of 1/2 x squared, we're talking maybe like 0.000126 or something like that. That would be the number that we're multiplying by to make it really shallow like that. Okay. Anybody know how a parabola works, by the way? What it does? It collects information. And so no matter where that information comes from, wherever it hits, boom, this shield bounces it to that point. That's called the focus of the parabola. We're not going to deal with the focus, but that's how a parabola works. Okay? That's how it collects information. So it doesn't have to point at the whole sky all the time. It can collect information from a wide range of places. You know, anything, even if it's coming from over here, you know, boom, it's still going to bounce back to that collection point, the focus. Okay? Same thing with old-time flashlights. That's how they focus the light better. Because that tiny little light bulb wouldn't light your room, but you put it in a flashlight with that parabolic mirror in there, and you've got some concentrated light. Okay, your car headlights work that way too. They used to. Now they're more LED stuff, but they still use mirrors and they still use parabolas in some way, shape, or form. All right, so anyway, let's continue here. Let's do another. I'm going to erase this guy, the end of this. Let's do another fraction one. Come on, baby. All right, so let's go like a fourth. So if I had y equals 1/4 x squared plus 1. So again, our vertex is going to be at 1, right? And then we're going to go up 1 over 1, but instead of up 1, we're going to go times a fourth. So that's going to be 1/4, right? So a fourth would be like really, really low right there, right? Okay. And then we got to go up 4 over 2. Well, what's a fourth times 4? That's 1, right? So we're going to go up 1 over 2. So this one's really shallow. Okay? But again, nothing changed except the idea of what we multiply our pattern by. So we've got the pattern that we need to memorize, or we need to know of, and we've got the negative makes it go upside down. We know where our vertex is. Okay? And then we use this number to change the vertical portion of our pattern. Remember, these two guys never change. The over 1 and over 2 are always over 1 and over 2. I don't go over 2, over 4, or anything like that. I'm always going over 1, and then on the next set I'm going over 2, and that's it. The only thing that changes is how much I go up and down. Okay, the over never changes. All right. Now, I'm going to give you 2 of those on the quick check. Okay, those will be real fast and easy, I think. Now we got to learn how to do when we have the external. So if I have something like this, x squared plus 2x plus 1. Now I'm telling you right now, that is not our vertex anymore. Okay, that's totally out the window because we're doing something. We've got to shift our line of symmetry and all kinds of things here. Now, it might be, you might get lucky, but you can't read that anymore, okay? You can't read the vertex off there anymore. So the first thing we got to do is find the line of symmetry, okay? And there's a formula for that. If you think back to when we were doing it here, and this was our line of symmetry right here, that line was x equals 0, okay? Remember that? A vertical line is x equals, and if it's on the y-axis, that's 0, okay? So our line of symmetry is always going to be x equals something, and it's negative b over 2a. Now, we haven't talked about this, but standard form is ax squared plus bx plus c, okay? And so in this case, a is 1, b is 2, and c is 1. And we don't care about c for right now. We care about these two. So I'm going to plug them in. If I plug in b here, I got negative b over 2 times 1. So that's negative 2 over 2. So that's negative 1. Notice that negative is always there. You could say the opposite of b. b is 2, so the opposite of b is negative 2. It's up to you how you want to think of it. It doesn't matter to me. I always say negative b, but if you want to say the opposite of b, that's fine as well. Okay? So now, here's the deal. We know that our line of symmetry is here. All right, at negative 1. Instead of being on the y-axis, like we have been, now we got to shift over. So this makes it in the, come on, baby, a little bit more difficult. Okay, so I'm going to label this guy up here. When we have y equals x squared plus 2x plus 1. And our line of symmetry, x equals negative b over 2a, was negative 1. So that's this line right here. That's where our line of symmetry is. But we still don't know where our vertex is. Okay? Now, when we first began, I says we don't have to do the XY chart anymore. But then I also said, and except for when we have this x term in here. So now we have to do the XY chart one time. We got to plug in this number, and that will tell us where our vertex is. And then we can follow the pattern again, the up 1 over 1, up 4 over 2. So let's plug this in here. So if I do an XY chart, and I put in negative 1 for x, y will be negative 1 squared plus 2 times negative 1 plus 1. Notice I plugged in the negative 1 into this formula, didn't I? I put negative 1 in here, and I put negative 1 in here. So this, again, the negative's in the parentheses, so that makes that positive. That makes this negative 2, right? And then plus 1. So in this case, that's 0, isn't it? So in this case, our vertex is right here, and that's fine. It's not always going to be on one of those lines. It could be, your vertex could be out here. It could be over here. It could be, it could be there. You just never know, okay? But in this case, it's actually on that line. All right. Now, I follow my pattern. My pattern is up 1 over 1, and there's a 1 here in front, right? Isn't there a 1 there? So now I just follow the pattern normally. So I'm going to erase this big dot I got here. So there's my vertex, and there's my up 1 over 1, and then I'm going to go up 4 over 2. So back to my vertex, 1, 2, 3, 4 over 2 would be here and here. So there's my vertex. All right. Let's try another one of those. We'll go on this graph right here. Let's say we got y equals 2x squared plus 4x plus 1. Okay. So now my A is 2 and my B is 4, right? So my line of symmetry is x equals negative b over 2a. So negative b would be a negative 4, or the opposite of 4 would be a negative 4, over 2 times 2 is going to be negative 4 over 4. So x is negative 1 again. It's not always going to be negative 1, guys. I'm just making them easy so we have easy math. And I'll try to give you easy math where it's not super hard to figure this out so you get a bunch of fractions and things, okay? I won't try. I will do it. You won't have fractions for your line of symmetry, because that gets kind of nasty when you try to plug it in up here. So anyway, our line of symmetry is right along here. Okay. Now we just got to plug this negative 1 in to this. So I got 2 times negative 1 squared plus 4 times negative 1 plus 1. So this is going to be a positive 2, because negative 1 squared is 1 times 2 is 2. This is going to be a negative 4, and that's going to be a positive 1. So this time, negative 1 is where our vertex is. So right here is where we go. But now, do I just follow the normal pattern? Well, no, because I have a 2 here. So I have to double my normal pattern. So normally I would have went up 1 over 1, right? But I got to double it. So times 2 is 2 up. And still just over 1. I don't change this guy. This guy never changes. And then I would go up 4 over 2. But again, I got to take this times 2. So that's going to be 8. So there's 1, 2, 3, 4, 5, 6, 7, 8. And then over 2 would be here and here. And that's a beautiful little parabola. Okay? So when we get this x term, it gets a little bit hairier. We got to do this guy. If we don't have him, if we just have y equals 3x squared minus 7, we don't need to do any of this. We can start at negative 7 and then triple the pattern. That's really easy to do. But as soon as I throw in this x term here, you know, this guy has an x squared, but there's no x in there. There's an x squared, but no x. Okay, as soon as I throw in that x, that throws off where my line of symmetry goes. Okay, and so we have to find this first and then plug in what we get to the original formula, and that'll tell us where the vertex is on that line of symmetry. Let's try one more of those, at least, and then do a review of all of it. Okay, because we got a couple more slides yet. We got a couple more we can do. So let's just use them all. This will be a long video today. All right, so let's go y equals x squared plus, let's go minus 4x, and then let's go plus 3, just for giggles. All right, so a this time is how much? 1, because there's a 1 here, right? And b is negative 4. So now my line of symmetry is x equals negative b over 2a. Well, the negative b, since this guy's already negative, that's going to be positive 4. And then 2 times 1 is 2, so 4 over 2 is 2. So my line of symmetry is on this line, so I'm going to use a different color. I'm going to use blue. How's that sound? The line of symmetry is that blue. That's pretty. All right. Now what do? How do I find my vertex? I plug that 2 into the original formula. I'm going to put that 2 over in here. Okay, so I'm going to go back to black here. So this 2 is going in this spot. So I got x squared minus 4x plus 3. I got 2 squared. There's my 2. Minus 4 times 2 plus 3. So let's see, this is 4 minus 8 plus 3. So what is that? Negative 1? 4 minus 8 would be negative 4 plus 3 is negative 1. That's right. So on my graph over here, negative 1 is right there. And that's my line of symmetry, 2, negative 1. Now, is A 1? If it is, we just follow the normal pattern, up 1 over 1. So we can go here and here, and then up 4 over 2. So I go up 4, 1, 2, 3, 4 over 2 would be here, and there is my parabola. Beautiful, so beautiful. All right. All right, let's do one more. Let's make one go down this time. So let's say I got y equals negative 2x squared plus 8x. I gotta think here. Minus 3. Let's see if that works. It might work. All right, so A is negative 2 and B is 8, right? So I got my line of symmetry is x equals negative b over 2a, which is negative 8 over 2 times negative 2, right? So that's going to be negative 8 over negative 4 is going to be a 2. Okay, so now we plug that into this. So I got negative 2x squared plus 8x minus 3. And if I put that 2 in there, that's 2 squared. That's 8 times 2. Oops. And then minus 3. So this is going to be a 4 times 2 is negative 8. That's going to be a positive 16 and a minus 3. So this is going to be 8. And that's going to be minus 3. That's going to be 5. So our line of symmetry is at 2, and the vertex is at 5 on that line. So if I go to 2 over here, and then 5 is where my vertex is at, right there. Is that 5? Looks like it. So there's my vertex. Now, I can't follow the normal pattern. I have to go times negative 2, right? So in other words, I got to go down. So I'm going to go down 2 over 1. So I'm going to be here and here. That looks askew because my line of symmetry isn't quite right, but it's the right spots. And then if I go times negative 2 here, that's going to be negative 8, right? So there's 5, 6, 7, 8, and over 2. It'd be here and here. And this is what that parabola would look like. Okay? Because remember, when A isn't 1, we gotta change this pattern here. Notice these two things have never changed the whole time. Every parabola we've ever done, we went over 1 and over 2, over 1 and over 2, over 1 and over 2. The only thing that changes is this vertical. When this number is not 1, we change that vertical. Okay? All right, so don't forget when, come on, baby. Ooh, that was wild. When there's no x term there, it's really easy to do. You just start at negative 7 and go up 3 over 1 and up 12 over 1. Okay? As soon as we throw that x term in there, you got a little extra work to do. All right? So I'm going to put up a quick check with 4 problems, and we'll go from there. Let me know if you have questions. Good work. Come on. How many crickets?